All right, physical science. Here we go. Okay, here we go, guys. Hey, this may be a little different, guys. I'm out here in my wood shop, and it's let's see, it's about 4 o'clock. It's pretty cold out here, to be honest. Got my little heater beside me, but I can't be inside right now in my own house, because my family's sick right now. We've got my wife a good while back now, but anyway, has tested positive for COVID. So, but she's doing great. She's doing great. Well, I say she's doing great. She's been sick, but she's doing good. She's more recovering. She's recovering, and she is feeling much, much better. And everything is going well. My little boys are doing. They're good. So everything is good. The worst thing really now is that I'm not going to be at school today, Thursday, or Friday. So, but it's not the end of the world by any means. I'll be back on Monday, and we'll be ready to rock and roll. But we're still going to do stuff here. So what I thought we'd do here is be able to record the notes. We could record the notes here. And I know I haven't printed these out for you yet. You don't have them. So what I thought you do is in your binder, you can take notes along as we go through them, as I speak through the notes, and then we'll be able to. I can get you the actual printouts when I get back, and you could fill them in then, or you could just keep the handwritten notes, and that'll be fine as well. However you'd like to do it. But that's what we're gonna do. And so, what I need you guys to do is just listen, is to watch and listen. I'm gonna try to make this short. I'm gonna try to make it about 25 minutes roughly. So you guys will have time to afterwards. I think I have a few sheets that I did get Coach Harris to print out for me, but you guys could kind of have some work to go along with this to use to kind of make sure we're reinforcing it. So as I speak through the notes, you listen, you write, and then of course we've got this is going to be. I'm going to put this is a screencastify, and I'm going to put it on YouTube. You may have just heard the rooster in the back. He's right outside the little shop here. Um, but uh, but um, but you'll be able to have these to help you with the worksheet that accompanies this. Okay, so man, I'll anyway, I'm gonna get back with you guys on Monday, and we'll be ready to go again. So anyway, this is a cool thing, man. This is one of the really cool things about technology that we can do. So I'm super excited about this, and I think it'll. I'm hoping it really works well. So, but what I need, guys, is from you, is for these next 3 days, is we're during class, man. Just do the best you can to just hang in there. Let's try to stay focused. I know it's not the best, uh, but to listen to me here and do great for Miss Schultz there as she is with you guys for these next couple days. Um, so please be on your best behavior as always. That's very important. Represent yourself appropriately, um, and me because you're in my classroom. All right, so here we go. Um, So let's talk about the classification of matter. So we're on new stuff, right? We went from electricity, bam, and now we're on matter. Okay, we're kind of getting into chemistry. So this is cool, man. This is going to get into the second half. We're going to be less math now and more kind of chemistry concepts. There's not really any or much at all math with chemistry. Okay, there's a little bit of stuff here, but not near as much. So if you guys didn't like the math stuff, you may like this side better, maybe. Okay. I know I love chemistry, so I'm fired up about it. All right. So classification of matter. Let me present this, and here we go. So I'm trying to be done in 22 minutes or so. Keep myself on that. Yeah. All right. Maybe. Okay. Classification of matter. All right. So guys, this a lot will probably be for the most part kind of a review. I mean, more than likely, it's from like middle school. But that's okay. All right, what is matter? Matter is anything that has mass and takes up space. So everything is matter. Everything that you can still see, taste, touch, feel, experience is matter. It makes up the air. You move your hand through the air, like we said many times, it's matter. You're touching it, right? Um, I guess there's nowhere on Earth you could go really to experience nothing, right? Really, could go to the only place to be is on Earth. You could go into space, and in the vacuum of space, I guess you could really maybe say I'm around nothing. There's nothing around me because there's literally no air, right? So there's nothing there. You can't really experience that on Earth, which so it'd be really weird, I'm sure. Um, so it says matter is either a substance or a mixture, and so a substance we read here, and this is I want you guys to focus on this here you can see this little this doohickey thing here is great. It kind of keeps you on track, right? Um, this keeps you on track to kind of matter. It can be broken down into substance, and you can break it down to mixture. And then we're going to break down substance further, and then break down mixture further. Okay, so that'll keep us in order, I think. Okay, so a substance is all particles in matter are identical, fixed composition. Okay, like elements on the periodic table. Look up on the ceiling in the classroom, right? Those are elements. That's the substance. That's elemental structures. Okay, um, mixture are two or more substances physically combined variable composition, right? And now they can be, we'll talk about two types of mixtures, right? You've heard them before. Homogeneous mixture, the same throughout, and then heterogeneous mixture, not the same throughout, different throughout, hetero, right? Homo, same, hetero, different. Okay, so let's get into them a little bit. Okay, two types of substances. Okay, so if we go here, back to our picture again, back to our picture. So we're here, we're going down the substance rabbit hole. And so we have an element and a compound. All right, so let's talk about elements first. So like we said, if you look on the periodic table, you have elements, right? Hydrogen and helium, lithium, beryllium, boron, carbon, like the song, right? The element song. So those are all the simplest form of matter, right? You can't break down an element any further, or it's not really, well, it's protons, neutrons, and electrons. Then it's not the same thing anymore. It's subatomic particles that make it up. So the term, the simplest form of matter from which more complex substances listed on the periodic table are made, right? Um, so example, or all the atoms that make up an element are alike. Okay, so if I had this, I would be really nice. If I had a big chunk of gold, if this bottle was a big chunk of gold, it would just be gold atoms. That would be it. That would be it. It'd be worth a whole lot of money. And I probably couldn't hold it up like this because gold's super dense and it'd be stinking heavy. So, um, but an example is helium, right? Element 2 on the periodic table. All right. So that's an element, the simplest form of matter from which more complex stuff is made, right? So what's more complex stuff, right? Say that, right? What if I take an element like hydrogen, okay, and bond it with oxygen, okay? What is that gonna make? If I take two of these, two hydrogens, stick them on here, right? I make a substance like water, right? Which is a compound, okay? Which is then this go the other way, okay? It's made of the elements. Compounds are made of elements. Okay. So elements can exist. Let's do this. Okay. All right. So elements, molecular look. So we're still on elements, and he says, okay, this is important. Elements can exist as individual elements or as them bonded together. So let's think about this for a second. Like the air you're breathing in the classroom right now, right? Actually, most of the air I'm breathing right now, and you're going to be breathing in the classroom when you watch this, is nitrogen. It's N2. It's this one down here, right? N2. Get my pen out. N2 is what you're breathing. Actually, about 78% of what you're breathing is N2. About 78% of it, which is a pretty good bit. That's pretty cool. And then actually about like 20 to 21% of it is oxygen. Right? That's about all of it, guys. That's like 99% of what is in the air is nitrogen and oxygen. And there's other small amounts of water vapor and carbon dioxide and other things that are very small amounts. You get to like really small amounts of stuff in there. Okay, but look at these. The point kind of this before I get off too much is okay. So elements like elements like argon, helium, neon exist as individual atoms. They're the noble gases. If you were to look on the periodic table, they're on this side of the periodic table. When you look at it, they're called the noble gases. It's 18, group 18 or 8A. It's another way to look at it. But on the periodic table, we'll look at it. They're super stable by themselves. They're like, leave me alone, I'm good. And we'll learn why that is. Okay. So they exist as individual atoms. They're just one of them floating around the room. There's argon probably floating around in the room right now. Like 0.0001% of the air in the room right now is argon. And it's floating around by itself. But other things like oxygen, nitrogen, hydrogen, they don't exist as what we call mono, means one. So monatomic atoms. They don't exist like that, like this, like one of them. They're actually always bound to each other. Like there's always going to be two oxygen atoms bound to each other because there's always oxygen atoms around. If they get close together, they're going to bond together. So you're never going to be by themselves. And then same thing with nitrogen, the same thing with hydrogen. So we call them, they exist as diatomic. Di means two. So some elements exist as diatomic elements. Some elements exist as monoatomic elements. So that's that. All right, that's elements, kind of how they exist. Do they exist as a monatomic element? Basically, are they a noble gas? Or do they exist as diatomic elements? Okay, like that. And there's more to the story than that, but that's enough for us now. Okay. What about compounds? Okay. Let's go over here. All right. So two types of substances. The second one is a compound. We just said a minute ago, if I were to take uh, two hydrogens and one oxygen and bind them together, I got water. So I have a compound here, a compound like water. Okay. Or table salt, right? If you take sodium and chlorine and put them together, you make table salt. Guys, this is actually really cool because if you did you know chlorine by itself it'll kill you, right? It's mustard gas. It's very dangerous. And sodium by itself is a metal. It's like, what the heck? But you put these two things together, add a little bit of energy, and boom, you have table salt. Very different. So compounds, and it says it down here in this bottom part right here, compounds have different properties than the elements that make them up. It's kind of neat. They exist, they function differently than the elements that make them up. So same thing for water, and same thing for sugar. Sugar is 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms put together to make sugar molecule. In other words, it's called glucose. And that's what we make energy from, glucose. You break glucose down and make ATP to make your brain work and make everything work. And that's every organism on the face of the earth uses that to make them go. They break down sugar to make ATP. Cool. All right. So that's a compound. Compound, 2 or more elements chemically combined in a fixed proportion. Okay. 2 hydrogens for every 1 oxygen. Water. All right. So the difference between an element and a compound, just kind of reinforcing this, an element is just one substance, the simplest form, O2, right? O2 is the simplest form. It's just oxygen, right? Nothing but oxygen in this case. It's O2. You could say, so it's a diatomic element. And a compound is 2 or more elements chemically combined together. And in this case, example, CO2, which is carbon and oxygen, combined together in the form of CO2. So 2 oxygens for every 1 carbon. Okay, the CO2, 2 oxygens. You can see a picture over here. There's our C, there's our 2 oxygens. Okay. Good. All right, so what have we done so far, right? We went matter. Matter is anything that has mass, takes up space. Everything you touch and see, that's matter, okay? And we broke down matter into a substance. All right, so you have an element and a compound. Elements, elemental stuff is what's on the periodic table, right? They can exist by themselves like the noble gases, or they can exist what we call monatomic elements, or they can exist as diatomic elements like oxygen, like nitrogen gas, like helium gas. But everything on the periodic table is elemental. That's the fundamental things that make up everything in the universe on the periodic table, on the ceiling of the classroom. Okay. And if you could have compounds, right? Compounds are 2 or more elements combined together in a fixed composition, like water, H2O. That's 2 different elements combined together to make a compound. Or you could have salt, sodium and chlorine. or sugar, C6H12O6. Those carbon, hydrogen, and oxygen bound together to make a compound. Okay. And then next we have mixtures. So we got matter, and then we can go off this other branch and go into mixtures. So mixtures are still made of elements, right? They're still elements. It's just kind of breaking it down in a different way. So it's not like this is made of different stuff. Everything's still made of these elements, right? And they still have compounds in them. Okay. So homogeneous mixtures are components. The components of the mixture are evenly distributed on a microscopic level. Okay. So that's important to understand. It's on a microscopic level. Usually, like if you look at the substance, it just looks like you can't see stuff in it. It is like a liquid substance. Okay. Um, and then so there's a good word. It says it usually appears blended. It usually appears blended together. Like it's you could say this looks like the same throughout. It doesn't what doesn't look like, like a bunch of like if you were to scoop up gravel or something, right? You'd say, well, it's not the same throughout. It's got some big rocks over here and some small rocks over here. That's heterogeneous. Okay, so it says solutions when one substance is dissolved into another are homogeneous mixtures. So, like when you put salt into water and blend it up, for example, sugar into water, like this lemonade here, and mix it up, the sugar evenly distributes itself throughout the lemonade. Okay, so it's a homogeneous mixture. It's even throughout. Okay, examples here: bleach, bleach, lemonade, coffee, uh, Coca-Cola. Um, all those things are homogeneous mixtures. All right, let's contrast that with hetero, not the same throughout. Not the same throughout. Salad dressing is a great one, right? You can see it doesn't like, oh, there's not maybe more pepper over here in a salad dressing than over here, right? It's not the same throughout. Just look at them. As you can tell, well, there's more up here though. There's oil and water. They don't mix, right? They're not the same throughout. They're a heterogeneous mixture. Okay. Um, so they can settle out. This scoop of cereal, right? There's not the same throughout. Um, so paint. Now, paint is because it will settle, right? Homogeneous mixtures don't settle out. They stay the same throughout. They don't settle out. Okay. Um, so salad dressing, paint, cereal are some examples of substances that are not the same throughout. I always think of like a scoop of gravel. If you were just to take some dirt and just scoop it up, that's a heterogeneous mixture. It's not the same throughout. You got different stuff in it. Not, you, that's, it's not that you have different stuff in it. Okay, it's that the stuff is not evenly distributed within it. That may be confusing what I just said there. Let's do that again. So both homogeneous mixtures, they have different stuff in them, right? Well, in this you have water and sugar. It's different stuff, but it's because the sugar is evenly distributed throughout the water. That's what makes it homogeneous. It's the same distribution of sugar throughout the liquid. Okay, that's important. Whereas in the salad dressing, there's different stuff in there, but the reason it's a heterogeneous mixture is the stuff that's in there is not evenly distributed throughout the liquid. Okay. Same thing for the cereal. Same thing for the paint. It's not evenly distributed. That's important. I'm going to confuse you. More with that, right? The difference between homo and hetero mixtures. And again, it says homo is even distribution, the same throughout. Salt water is a great one, right? The salt is evenly distributed through the water. The heterogeneous is salad dressing. The different molecules in there are not evenly distributed throughout. Okay. All right, let's see here, guys. All right. Again, this little chart I think is good to keep us like our brains in order, right? So we start off with matter. Okay. Then we go to anything that has mass and takes up space is matter, right? Okay. Then it has, okay, a substance is a fixed proportion or physically combined. Over here is mixture. We broke down the substance into elemental on the periodic table. That's what PT means. Then a compound is chemically combined, right? It's chemically combined. It's elements that are chemically bound by chemical bonds. And then a mixture can be the same throughout, homogeneous, or different throughout, heterogeneous. And we're talking not about the stuff, but about the how the stuff is distributed through the mixture. Is it the same throughout the mixture? It's homogeneous. Is it different throughout the mixture? It's heterogeneous. Okay. All right, guys. Was that it? It went too quick. No, that's good. Okay, so that is it. All right. So I believe, if I'm not mistaken, uh, Miss Schultz should have a worksheet that goes with this. And guys, this is really uh, simple stuff from the standpoint of well, it's never you've had it before. How about that? You've had it before, so hopefully it's stuff that you're grasping. But sometimes this heterogeneous, homogeneous stuff can be a little confusing, man. It's like stuff that you thought was hetero is homo or vice versa. So you got to kind of practice that a little bit. Remember, it's about the composition throughout. Is it the same composition throughout, different composition throughout? Notice, are you kind of grasping what an element is and what a compound is? Okay. What's the difference between an element and a compound? All right. Do you know that? Could you describe that to someone? Could you teach it to someone else? All right. Ask yourself that. Well, hopefully the worksheet will help you with that to see if you can get that. Okay. So I'll be, like I said, I'll make another one of these tomorrow and post it for Thursday. And but these will all be on YouTube. This is where this is going, is on YouTube, and it'll be just like we've been doing in class, making some YouTube videos. You can go back and watch the lectures. And but I hope this is helpful to you. And I'll be back with you guys soon, and we'll get back rolling with our normal stuff. All right. Thank you guys for listening, and I'll see you soon.